Right, okay, we're making a crank trigger 36-1 to go on the front of our Ferrari pulley. And I've got this off, had a look at it. What I want to do, I want to run it on this diameter. So rather than machining this, I'd like to leave this totally standard. I don't like modifying things, because if we have a situation in the future where, say, this pulley gets worn out or damaged, I want them to be able to swap whatever I've made straight onto their pulley, so they haven't got to re-engineer everything. So the plan is, I'm going to bore, I found this old bit of scrap aluminium. It's actually, well, I'm a hoarder, and I was looking at this and I thought, why has it got them drill marks there on the side? I've used this as a liner pulling tool, and then I've got something else for my liner pulling now, so it's redundant. And then I realised where this has come from. Now, you've seen the spacer plate engines where I've had them water jet cut, but the very first one I did, which is going back a long time now, I made it out of a big piece of valley, and I just got it on the Vadar drill and drilled hundreds of holes until the centres fell out. And that is one of the centres that I'd kept, and then I've turned it. So there you go. Never throw anything away, because you just never know when it's going to have a secondary use. And now, having been a liner puller all its life, secondary life, it's now going to get a third life on a Ferrari. What a lucky bit of alley you are. So I'm going to put this in here, in the lathe, sorry. I'm going to bore it, face it, because then we'll be able to clock it up off the inside, flip it round, turn the outside after we bored this. This will have to go in a 4-jaw because it's too big for the 3-jaw. And then we'll see if we can make it all work and find a way of screwing it together. Okay, brilliant. I'll crack on with this, and I'll set the camera up maybe so you can see what I'm up to. Right, okay, we just done part one, which was to bore the old liner puller. So I've faced him, bored him. I didn't use measuring equipment to get there, because I'd need loads of time and really good measuring equipment. So I've got him roughly to within about 10th thou, and then because this is off the engine, I've been able to just off rim up and keep tickle cutting until we got there. So this fits on here now, nice and snug. And there's a bit of temperature in this alley as well, so it will be a bit tighter when it cools down. Obviously, this being steel, this being aluminium, has a higher expansion rate. So what I'm going to do now, I'm putting him in the lathe the other way around, and I'm going to top turn him, face this face here, just to clean it up, choose how far down we're going to go, and then what will happen is we'll bore the crank trigger for him to sit on. So we need enough land on that spigot to get some screws into the steel, because we can tap into the steel, some nice M4 cap heads or something, and then we can have him permanently fixed on there. He'll slip on there, we can grub screw him when we've got him in the right place. The job will be spot on. Okay. Okay, finished the first part now, which was the spigot that we've made that's now gone cold and got stuck on my pulley. So this is the spigot. I've just top turned it, and what we're going to do is we're going to sit the steel trigger on that face, drill through and tap into the steel. Just some nice little M5 grub screws, cap head screws, sorry. And then that'll be permanently fixed to this, and hopefully we'll have enough land to get alongside and put a thread in down to locate it permanently in its position. What we'll do is we'll drill through and dimple into this shaft, so that when we put the pinch screw in one each side to equal it out, it locates it. So put a little dimple in there for the screw to sit. But we're not massively modifying the original Ferrari front pulley, because it's probably about £3,000 or something. Anyway, what we'll do now is I'm going to bore this. I'll drill it first, I'm going to bore it, but I thought I'd just stop the time lapse and go on to normal video for a second, just to explain what I'm doing. Now, obviously, because we started off with a rough piece of alley here, I top turned it, I faced it and I bored it and I top turned it, then I turned it round and I've used the jaws to come off the surface that I just turned. I know my jaws are good for about 3,000, so I know that all this is concentric, so I'm happy with all that. But this, because it's in the forejaw and the jaws operate independently, what we've got to do is put a clock gauge on the little bore that it came with, and that'll help me to centralize the by moving each jaw independently. I use the clock gauge. I have done another video on this called lightening a flywheel or something, so if you want to look at that, that'll explain it a bit more, but we won't go too down that road. I'm just going to clock it up now, drill it, bore it, get it to fit on there, and then we're ready to drill and tap. But what we'll do before we do any of that, before we move anything permanent, we'll offer it up to the engine and see if it looks like it's all going to fit correctly. Right, I've drilled that and bored it now. So again, using measuring equipment would have been nice, but because I've been here before and measured things and took a thou here and took a thou there, and all ends up scrap. So I've done a bit of engineering feel, we'll call it. Crept up on it gently. We've got a lovely nice fit now. So it's time to remove this off here, and we'll go and offer it up on the engine and see if we can decide where we want to put or mount the crank sensor, because obviously that's the next important thing. So we'll make nothing rigid. We'll just put it all together so we can see how it's going to look. It looks something like that. I'll just unmount the camera. Okay, I've just mounted the pulley on the front of the engine and it all looks really good. This casting does come a bit further forward than I first thought, so I'm glad we haven't done anything rigid. I would have liked to have had it as close to the where we're going to mount it as possible, but it's not a problem. This is a Ford CVH or Z-Tech type crank sensor, and these are really good because if you have a failure, they're so available. Everyone's got one in the toolbox, so you can always fix the thing. So we want to put it on, I want to mount it off here. And I think what we're going to do is make a nice block of alley to slide him into so that it's really rigid, because you can't just mount these crank sensors on like a piece of steel and hang it off the front of there, because the harmonics of the engine, what you get is, you'll see it on the dyno, they get a wiggle on, and then we start getting misfires and it not reading the trigger properly. So we want a nice block of alley to support at least 2/3 of that stem there. And we'll bolt it to here, and we could also do with a mechanism where we can just adjust the height ever so slightly, because I doubt if any of this is doweled on. It's probably just located, you know, loosely, so we need to make sure that we've got a way of adjusting it. So we'll tackle that next. Okay, back with the crank sensor mounting position. I've just put the trigger wheel on with the new Boss, and I'm really pleased with it. I've actually drilled and tapped it as well, so it's got a few screws holding it on now into the steel. What I want to do next is I want to mount this crank sensor. So it's going to be fairly close, as you can see there, oh, wrong way, sorry, to the timing belt cover. And I've got this piece of aluminium angle iron that I've just chopped up. I've used this stuff before, it's quite good. What we're going to do is we'll drill and tap that from the back so it's bolted on, and then we'll drill a hole in the top here, and then I'll keep it in the lathe, and what we'll do is we'll use a boring bar to put a radius the full length of that, and that'll give the the crank sensor, the support from the back, but you'll understand more in a minute what I'm trying to explain when you see it being done. Right, okay, I've got the aluminium bracket for the crank sensor in a 4-jaw chuck. And what I've done, very simply, is I've centre dotted where I want the hole to start. Now what's going to happen is, as this drill breaks through into here, it's going to get pushed off. This is smaller than the size that we need for the crank sensor, which is here. So this is 12.5mm and this is like 13.5mm. So we've got a milli left, and what we'll do is we'll go in with the boring bar, because that's only a single point of contact, so it won't push that off. And what we'll see it do inside there, which I will try and show you as I'm doing it, is we'll see a radius appear on that back flat, and that is what we're going to use to support the crank sensor so it doesn't get vibration and harmonic issues. Okay, I'm going to put this on the time lapse now so you can see from there. Right, just finished boring this now. So I drilled it and bored it, and I've got to say, it's worked out better than I ever possibly imagined. If you can look through the hole there, you'll see where the boring bar has created a nice radius that'll support the crank sensor all the way to its destination. Look at that, beautiful. So we'll get this bolted on the front of the timing cover now, and we can actually see if it's all going to work out correctly. Okay, we've now got the crank trigger mounted on the Ferrari front pulley, and the crank sensor is mounted on the timing cover. So that's all worked out really well. I'm really pleased with that. It's got a nice radius, as you've just seen in the 4-jaw when we had the piece of aluminium angle in there. So it's all nicely supported. Now I put a couple of little grub screws, one there and 180 opposed, and what they're going to do is they're going to pinch this aluminium boss that I've made that's sat on the outside there. And the reason I've left them loose is, just check that all looks good. Yeah, got my clearance there. So I don't know if we're able to spin it or not. No, it's too tight. Oh, there you go, it's just turning. So that's nice and tight. What I'll do is I'll put a little bit of pinch on these. We'll set it up with 90 degrees before, because the relationship between this crank trigger gap when it triggers the ignition to fire and the position of the pistons is critical. So you do get something in the brains when we set it up on the computer, which I'll go through with you, which is called an ignition offset. But I really hate it when we've got like 8 degrees offset to make it see the correct timing at the engine. So say that the computer says it's 10 degrees before top dead center at 1000 RPM, and I come out here and I put the trigger on it, I put the timing light on it, and it says I've got 14 degrees, so I need to lose 4 degrees. Well, you can put an offset in the computer that'll make that correct, but what I really would like is if I can move the trigger in relationship to the pulley to get it so I've got 0 offset in the computer and the advance absolutely spot on. So 10 degrees on the screen is 10 degrees at the engine, and then we've got a good chance then. What we'll do is we'll creep up on it gently with the advance curve, and we'll get it so it's absolutely spot on and nice and safe and doing the power, and it can go in the out tray and we can get paid. Hope you've enjoyed the content of this little not manufacturing but engineering process of making a crank sensor bracket and the pulley. Bye for now. Right, morning YouTubers, it's Thursday morning. I've just put this Can-Am's spark only ignition system on this. The bloke very kindly, whoever it was who set it up, put coil front on it, coil rear, even numbered the coils. So I just copied his instruction thinking this will never go in a million years, and I put a bit of fuel in the carbs and it made a noise like it was going to go. So I thought I'd put the camera on so we could experience it together. I'll just give it a little bit more fuel. I've got some leaks on the fuel pipe, I'm going to have to replace it, but I was just keen to get a bit of a noise out of it. So we'll just give it a bit of fuel. That'll do for now. A couple of pumps. We'll see if we get a tune again. That sounds very retarded. Now, you might remember I didn't put the pinch screws on the crank trigger because I wanted to set it up perfect. So it goes that way, so we'll give it a bit of advance. Let's see if that helps him to fire up. Maybe it reads it the other way. That sounded even worse. How sweet. Still retarded. Interesting that. So it doesn't work the way it must read the tooth and then read back from it because I'm going the wrong way to advance it. I'm going in the direction of rotation. Okay, a bit more fuel. We'll get this fuel pipe replaced and get some water in it. Just run it for 10 seconds max. Wonderful. Right. Well, there's no nasty noises, so we'll get some water in it and some fuel and pipe, and we'll have a tune out of that.